Yeah, we'll switch gears and talk about a programming framework that came out publicly about 2 months ago, called ServiceWeaver. You can see it on you can visit the website if you're curious. The framework was really designed to solve the age-old question whether the application developers face whether you should write everything as a monolith or you should write things as microservices. I feel like, as Matt Klein mentioned, microservices have been all the rage in the early 2000s, and they're slowly becoming even more widely used for monolith is a bad word. You should just use microservices. And but microservices do come at a cost. And the cost is that they're harder to develop because you have to worry about versioning and versioned upgrades. Harder to deploy, you have a lot of config files you have to manage, and harder to maintain because now you have distributed set of things that you have to monitor and so on. So we've come up with the ServiceWeaver as kind of an in-between between a monolith and microservices. So you write a single modular binary. And then when you deploy it, so you basically write a monolith, but when you deploy it, it kind of partitions itself into a set of connected microservices. And I'll give you a little flavor of how it looks, what you're writing and so on. But at a high level, when you write your application, you write a single binary and you define a set of components in it. Component is just a Go interface or Java interface. For now, we just support Go. But you've defined 3 interfaces, rock, paper, scissors, and then you write inside those implementations of those interfaces. Rock can call paper, scissors can call rock, and you just use regular Go method calls. And then when you decide to run it, you could run it locally, all in the same process, or you can run it in a distributed manner, and we support some cloud implementations of this. So it effectively delays the decision of how these things are going to run in which processes and where to the actual deployment time. So I'll give you a little flavor of how would you define a component and how do you call other components. So like I said, a component is just the regular Go interface. So this is how you would define a cache interface with a method put and possibly other methods like get and so on. And then you would define an implementation. This is again typical Go code where this cache implementation implements the cache interface. It has the same signature for the put method. We require the user to add this embedding into their implementation to tell us that this is actually a distributed component. And then you would write your main code just like you would in Go, except you have to initialize our framework, and then you can get a handle to cache and so on. So, and then if you want to call methods on cache, these methods look just like regular Go method calls. And depending if cache is local or remote from the main function, it's either becomes a network call or a local method call. And now when it comes time to compile this binary, it's time to deploy it. You specify a simple config, and then you can decide which components you want to run together and which ones you want to run separate. By default, everything runs separately. And you specify a rollout duration, and then with the single command that go run, you can run it locally in the same process. So you can debug it locally, or you can deploy it locally, but run it as everything in a different process. Or you can deploy it on a set of machines. So in this case, you specify a set of machines you want to deploy to, and the deployer will just SSH and deploy to them. Or you can deploy on GKE. Here, these are just simple commands with a little bit of extra config. You specify the regions you want to deploy and which listeners should be publicly exported. So, and it's, like I said, this config is a few lines of code, so we're very opinionated. We don't allow users right now, at least, to configure the network. We configure the network, we configure the deployment, we decide where things run. By default, everything runs distributed. So I'll give you a little insight in how things look when they're deployed. So again, you start with the modular binary, define your components, and then when you deploy, these components all get split into different processes that can be replicated. And you link inside your binary a bunch of our libraries, and then all the implementation, those libraries communicate with the environment, which can be either a local machine, a set of machines using SSH or GKE, and in the future, we hope to support other cloud providers. So to the user, it's completely irrelevant where it's running, and it's up to the platform to support this protocol that the application uses. I have a quick slide on performance. So we implemented our own TCP-based transport. We do our own client-side load balancing, and because we promise that all the components are deployed at the same version, so there's no cross-versioning issues. We don't use protocol buffers. We use a very efficient binary transport. So on this table, we have Kubernetes, non-Weaver application. This is gRPC and Proto. In the middle, we have our deployment with everything running as separate Kubernetes pods or deployments. And then in the right, we have the same deployment, but everything runs in the single process on GKE. So you can see that we're more performant. We don't use sidecars. We use, again, proxyless communication. We're in process of adding MTLS. So the user, I'll just go back to this point. The user just writes this call at the bottom. It just calls a method. And if the cache is local, it'll just be a local method call, no overheads. And if it's remote, then we inject a lot of stuff like we're in the process of adding MTLS. We do client-side load balancing. We do tracing, metrics, and so on. So yeah, so that's it. I think I've managed to fit in the time slot. I have time for questions.
Oh, thank you.
I hope I gave you the flavor of it. I didn't want to spend too much time on, discussing microservices versus monolith, but I think we've seen a trend where people oversplit things into microservices and realize that this is just becoming unmanageable. And then they at least take some parts of their systems and they try to, they go back to the good old monoliths, which is much more manageable and less complex. I think there are very legitimate reasons to split things into microservices, like different teams, different rollout schedules. But in an organizational chart, at least at Google, we found that people tend to oversplit. So a team would run on average 7 microservices just for a single logical application. And so this is where we think our system is helpful. So we're not saying you should take your entire organizational tree and write it as a single binary, but on the level of a team, you could maybe consider not splitting that much.
So so just following up on that thought, like, so if this is not my complete, well, there's no such thing as a complete application, I suppose.
Yeah.
But the idea is that I could have like a large distributed application which is partially Weaver and partially more traditional service mesh. Is that how you think?
Yeah, I think I would like to think of ServiceWeaver as a collection of distributed processes that are logically a single unit and that have a common HTTP interface, for example. So in other words, it's almost like a subtree of your entire RPC tree that a team controls, and that they don't want to pay the overhead of maintaining 10 jobs. Instead, they just have a single job, logically.
Got it. Okay. I think I should not hog a bunch of questions. Let me just walk through that instead. Let's see, which one was the first one? Okay. Let's start with visions. It seems that some of the functionality overlaps with Kubernetes in the long-term vision. What is the relationship between ServiceWeaver and Kubernetes?
So yeah, we're trying to be not heavily Google oriented, not even Kubernetes oriented. So our deployer implementations can come in many flavors. And so we don't have a formal relationship with Kubernetes. It's just that we see Kubernetes as an easy way for you to run your application in many places. So if we had the proper Kubernetes environment implementation, then it will allow people to run on EKS, GKE, and so on. But for now, we have a very, very GKE specific support.
Mungjin has a question around, can ServiceWeaver support multi-cloud deployment?
Yeah, so for us, so there's two definitions of multi-cloud, but we have not even tried to support like running one component on AWS and another on Google Cloud engine. That's I feel like too much for us to chew on right now. But there's nothing that prevents you from running your application on GKE, and then if you change your mind, you can deploy it on AWS if that support exists. And let me answer this question because Abhishek is watching. So can you elaborate a little bit further? Why not simply using gRPC as your transport? So we started on this project about 2 years ago, and at that point, the gRPC XDS support was just very nascent. And so we found, load balancing was a bit of an issue because gRPC uses HTTP2, and all of the Kubernetes service is an L4 load balancer, and it didn't integrate that well with gRPC. So we decided to do our own client-side load balancing, and then it made sense. If we're doing that, then it made sense for us to just use a slightly lighter protocol. But now that XDS protocol support is more mature, we can consider moving back to gRPC for sure, so we don't have to manage our own transport.
See, it's cool. There's a question from Mark. I assume this works only in a closed system within quotes, in the sense that all the interactions with Weaver component are split off in their own microservices, come from the same program, not from clients written separately. How do you handle automatically scaling individual microservices?
Yeah, so we rely for automatic scaling. We rely on Kubernetes auto scaling, and GKE has some more advanced autoscalers. And we do run our own control plane. So in addition to your application, we deploy additional daemon jobs that look at the existing, not try to detect, but they detect the existing replicas and then they update the client. So it's almost akin to implementing the sidecar proxy or envoy, at least as far as load balancing is concerned. So then, if the microservice gets scaled up, these daemons will notice and then update all the clients with the updated set of replicas.
Okay. So
And
there was
and the final question, I think, was about us having to implement all of the service mesh features. Yeah, that's correct. So we are reconsidering what we want to do here. We're currently adding MTLS. I'm really scared about us supporting other languages, so that's why I asked Abhishek about his opinion of having a non-sidecar, basically proxyless implementation. Yeah, I'm concerned that we'll have to spend a lot of time supporting other languages, and then how much, yeah. Definitely sidecar is very appealing in that way, but the performance impact is significant. So, yeah.
So one other question, do you come across like teams inside Google or outside, like wondering, like, can I VVify existing code, or this is only for brand new code?
You can. I mean, we're fairly restricted in that you have to use Go, and right now you can only run on Google Cloud or locally or SSH mode. We've actually Weavified like the online boutique app, which is a demo app that's widely available. and it was mostly deleting code. So regular microservice, you have to write an HTTP. You have to create an HTTP server, register gRPC, set up gRPC. You have to add a lot of cloud-specific logging, tracing, metrics code. So all of those functions are subsumed by a framework. So it was, yeah, it was. If I can go back to the final slide, you can see the lines of code. The non-Weavify code was 2,600 lines. We're 2011. So some amount, all of that is networking in gRPC code, but the config code and YAML files, of course, we're more opinionated, but even so, this difference between 1,500 lines of YAML code to 9 lines shows you that maybe there's some place in the middle where most people should exist. And even though we say, okay, 9 lines of code, but what if I want to configure this or that? I think that's all a fair point, but I think we can all agree that 1,500 lines of YAML code is a bit much. And then we don't use protobuf, we use the native types. So because we don't care about versioning, because both server and the client are the same version, we have our own serialization protocol and so on.
But the same version thing will shape out differently, right? If you have long running things like where, or how do you see that happen? Like
so we're targeting serving systems. So an HTTP request comes in, and then everything else is just internal communication. And we do blue-green deployments, and we rely on blue-green deployments. So to us, actually, to me, working at Google, this version upgrade problem is real, and it's painful. Because you have to worry when you're making cross microservice changes, you have to worry, what if I'm talking to an older server? What if I'm old and I'm talking to a newer server? And a lot of engineering time goes into worrying about how this thing will be rolled out and what are the implications of this version differences. So we've adopted a blue-green approach. You just change your code in the binary and redeploy, and you'll never have to worry about versioning issues, at least in terms of the application logic. And we rely on auto-scaling to basically slowly shift traffic, and then auto-scaling should ideally shrink the old version and grow the new version over time. So yeah, and that was a big pain for us, actually. To do blue-green deployment on Kubernetes is not easy today. Envoy helps and Istio can help, but the Kubernetes was built with rolling updates in mind, and to try and do blue-green deployment, especially with external load balancing, was a big pain for us. So
got it. Cool. Well,
thank you.
Thank you. Yeah, we'll come back to this.
Yeah.
Is super interesting. Yeah.
Thanks.